Today's lesson is how to add, subtract, and multiply polynomials. So your essential question is, how is adding and subtracting polynomials different from multiplying them? So let's take a look at a few examples. You can add polynomials either vertically or horizontally, but when you're adding, you have to combine the like terms. And to be considered like terms, they have to have the same variable and the same exponent. Now, when you're adding horizontally, you want to make sure that you line up the like terms. So the first example we're going to try is adding 2x cubed minus 5x squared plus 3x minus 9 and x cubed plus 6x squared plus 11 in vertical format. So when I rewrite this, because I'm doing vertical format, I want to make sure that I line up the like terms. So I'm going to line up 2x cubed and x cubed. And I'm going to line up negative 5x squared with 6x squared. There is nothing that is like 3x, so I'm going to leave that blank underneath on the bottom. And then I'm going to line up negative 9 and positive 11. And then I'm just going to add them together. So anytime there's just an x, that really counts as a coefficient of 1. So 2x cubed plus 1x cubed would be 3x cubed. 3x cubed. And then negative 5x squared plus 6x squared would just be 1x squared, so I'm just going to write x squared. The 1 is optional. Then 3x plus nothing would just be 3x. And then negative 9 plus 11 would just be positive 2. So this would be our answer, and notice that it's in standard form. We always want to start with the highest exponent and then go in descending order from there. Here's an example in horizontal format. And with horizontal, you really just have to pay attention to starting with the highest exponent and working your way down so that your answer is in standard form. And you really make sure pay attention to your signs. So we would combine 3y cubed with nothing else because there's nothing else that has a cubed as an exponent. So it would just be brought down. So we have 3y cubed. And then we would combine negative 2y squared and negative 4y squared. So negative 2 plus negative 4 would be negative 6y squared. And then we have negative 7y plus 2y, which would be negative 5y. And then there's nothing to combine with the negative 5. And so that would be like 0 plus negative 5, which would be negative 5. So this would be our answer in standard form. Now, when subtracting polynomials, it's very similar to adding. You're going to just combine the like terms, and they have to have the same variable and the same exponent. And when you're subtracting, and this should say vertically, when you're subtracting vertically, you want to make sure that you line up the like terms. And I don't know if I said that with adding too. Yeah, this should say vertically instead of horizontally. I don't know why that was on there. So when I'm adding or subtracting vertically like this, I want to make sure I line up the like terms. So I'm going to subtract 3x cubed plus 2x squared minus x plus 7 from 8x cubed minus x squared minus 5x plus 1 in vertical format. Now notice the way that this is worded. It's saying we're subtracting 3x cubed from 8x cubed. So when I write this vertically, I'm really going to write this value, 8x cubed, this line on top. So I'm going to write like this. Now when you're subtracting, you really need to make sure that you pay attention to your signs or you will get the wrong answer. So if I have 8x cubed minus 3x cubed, I would get 5x cubed. And then this counts as a 1. So negative 1x squared minus 2x squared would be negative 3x squared. And then this one counts as a 1 also. So negative 5 minus negative 1. So if I take negative 5 minus negative 1, I'm really adding. So that's why it's important to pay attention to your signs. So then I would get minus 4x. And then I have 1 minus 7, which would be negative 6. So that would be our answer in standard form. Now you can go back And something else that you can do, an expression that I've heard other teachers use, is draw the line, then change the signs when you're subtracting. So after we've written our problem and we draw our line, we can change all the signs. So this becomes plus a negative, and then positive, and then negative. So now we're actually adding, and it makes it a little bit easier. So 8x cubed minus 3x cubed would be 5x cubed. And then negative 1 plus negative 2 would be negative 3x squared. Negative 5 plus 1 would be negative 4x. And then 1 plus negative 7 would be negative 6. So you see we came up with the same answer, but we added instead of subtracted, so we didn't have to really pay as much attention to our signs. So that's another method you can use. Now we're going to subtract 5z squared minus z plus 3 from 4z squared plus 9z minus 12 in horizontal format. So we're going to write it like this. Remember, we have to pay attention to the wording. We're subtracting 5z from 4. So this one actually comes first. So we have 4z squared plus 9z minus 12 minus 5z squared minus z plus 3. So from here, if we write the answer, 4z squared minus 5z squared would be negative 1z squared, and the 1 is optional, but you can write it if you like. Then we have 9z minus negative 1. So minus and negative would turn to addition, so that would actually be plus 10z. And then we have negative 12 minus 3, which would be negative 15. Now you can kind of follow the same example that we did last time when we were adding or subtracting vertically. You can kind of do the change the sign thing. So if we go back, then we can do, I always call it keep, flip, change, because I really like Kentucky Fried Chicken, so KFC. Or you can just draw the line and change the signs. So we only change the signs of the second ones, where you can do keep, flip, and then change all the signs of these. So now we're adding, but it's the same thing. So 4z squared plus negative 5z squared would be negative 1z squared. And then 9 plus 1 would be positive 10z. And then negative 12 plus negative 3 would be negative 15. So again, we come up with the same answer. We just changed it to an addition problem. So now we're going to be multiplying polynomials. So this is a little bit different from adding and subtracting polynomials. You have to distribute each term of the first polynomial to each term in the second. So we're not doing anything with like terms like we did with adding and subtracting. We're distributing. So I have to take negative 2y squared times both of these numbers over here. So negative 2y squared times y would be negative 2y cubed. And negative 2y squared times negative 2 would be positive 4y squared. Okay, then I'm going to distribute the 3y to both terms. So 3y times y would be 3y squared. Then 3y times negative 2 would be negative 6y. And lastly, I distribute the negative 6. So negative 6 times y would be negative 6y. And negative 6 times negative 2 would be positive 12. So now I've distributed all of the terms. And so I need to simplify. So I'm just going to combine any like terms that I can. Well, there's nothing that can be combined with negative 2y cubed, so I'm just going to bring that down. And then I can combine 4y squared plus 3y squared, so that turns into 7y squared. And then I can combine negative 6y with negative 6y, so that becomes negative 12y. And then I have positive 12 that I can bring down. So that would be my answer in standard form. Now there's another method that you guys may not be familiar with called the stacked method. And I really like this, especially when I'm multiplying a binomial with a trinomial, because it's easier to keep everything lined up, and that seems like it's less steps. So I'm just going to rewrite this as 3x squared minus 2x plus 4 times x plus 3, and I'm going to stack it, and then I'm going to multiply it like I used to when I was in grade school. So, and it doesn't matter which one goes on top or bottom, because when you're multiplying, you'll get the same answer. So if I take 4 times 3, I get 12, and it's positive 12, so I want to keep the plus sign in front. Then I take 3 times negative 2x, which would be negative 6x. Now you might remember when you're multiplying like this in grade school, you have to bring down a 0. Okay, then you take x times all the numbers. So x times 4 would be 4x, and it's positive. And then x times negative 2x would be negative 2x squared. And then x times 3x squared would be 3x cubed. And then when you multiplied with regular numbers, you added everything together. So I get 12, and then negative 6x plus 4x would be negative 2x. And then I have negative 2x squared. And then I have 3x cubed. So this would be my answer in standard form. So you can do the stacked method if you like and have everything nice and lined up, or you can do the distributive method also. So you pick which one you like better. But remember, when you do the stacked method, it's just like if I was multiplying like 11 times 12. It's the same method. I take 2 times both numbers. So 2 times 1 would be 2. 2 times 1 would be 2. Bring down the 0. Then 1 times 1 would be 1. 1 times 1 would be 1. And then you add them together. So you get 132. So it's the same process as multiplying regular numbers. You just multiply the 3 by everything and then the x by everything and then add everything together. Now, when you're multiplying 3 binomials, you can use FOIL. I know some of you guys are familiar with that, first, outside, inside, last, but we use double distribution most of the time. So you're going to double distribute the first two, and then after that, you can take that answer times the third one. So I'm going to multiply the x times both numbers. So I would get x squared plus x. And then I would multiply the negative 5. So I have negative 5x minus 5. And then I can combine like terms. So I have x squared, and then x minus 5x would be negative 4x, and then minus 5. So that's my answer when I multiply the first two binomials together. Then I have to take that times the last binomial, which was x plus 3. So I'm going to do the stacked method from here, just so that you guys can get some more exposure to that, but you don't have to do that. If you're using the distributive method from here, you would take x squared times all the numbers, then you would take negative 4x times all the numbers, and then you would take negative 5 times all the numbers. So I'm going to go ahead and do the stacked method over here, and then I'll do the other method down here. So if I was to take x squared minus 4x minus 5 times x plus 3 using the stacked method, then I would take 3 times negative 5, which would be negative 15. 3 times negative 4x would be negative 12x. Then I bring down a 0. Then I have x times negative 5, which is negative 5x. And then x times negative 4x, which would be negative 4x squared. And then x times x squared, which is x cubed. So if I add everything together, I get negative 15. Then negative 12x plus negative 5x would be negative 17x. Then I have negative 4x squared and x cubed. Now let's see if I come up with the same answer over here. So if I distribute everything, so I take x squared times both numbers, x squared times x is x cubed. X squared times 3 would be 3x squared. Negative 4 times x would be negative 4x squared. Then negative 5 times, I'm sorry, I skipped one. Negative 4x times 3 would be negative 12x squared. Then I take negative 5 times all the numbers. So negative 5 times x would be negative 5x. And negative 5 times 3 would be negative 15. So if I can combine all my like terms, I have x cubed. And if I combine these, I would have negative x squared. And then if I combine these, I would have negative 17x. And then I would have negative 15. Now my answers are different, so I must have did something wrong over here. And I think I found it. I took 3 times negative 5 and I got negative 15. Then I took 3 times negative 4x and I got negative 12x. But I forgot to take 3 times x squared, which would be 3x squared. So then if I add those together, this would actually be negative 1x squared. So then they are the same. So you can see you can use the stacked method or you can use the distributive method. You should come out with the same answer. Now the cube of a binomial. If I have x plus 5 cubed, when I cube something, that means I'm really multiplying it by itself 3 times. So that would be like x plus 5 times x plus 5 times x plus 5. So you're going to do this in the same way that we did the last problem. So you're going to go ahead and multiply the first 2 together like this. So we would have x squared, and then x times 5 would be 5x, and then 5 times x would be 5x, and 5 times 5 would be 25. So if I combine like terms, I get x squared plus 10x plus 25. Then I multiply that by x plus 5 one more time. So again, you can distribute or you can stack it. If I stack it, I have x squared plus 10x plus 25, and then x plus 5. And this time, hopefully I will do it correctly. So I have 5 times 25, which is 125. 5 times 10x, which is 50x. 5 times x squared, which is 5x squared. Then I have, to bring down my 0, then I have x times 25, which would be 25x. X times 10x, which would be 10x squared. And then x times x squared, which would be x cubed. Just going to put that in there. Then I add together, so I get 125. And then I have 75x. And then 15x squared. And then x cubed. Let's see if I get the same answer this way. So x squared times all the numbers. So x squared times x equals x cubed. X squared times 5 would be 5x squared. Then 10x times both numbers. So 10x times x would be 10x squared. 10x times 5 would be 50x. And 25 times both numbers. So 25x. And then 25 times 5 would be 125. So if I combine all the like terms, I get x cubed plus 15x squared plus 75x plus 125. So either way, I end up with the same answer. So you can stack or you can distribute, whatever you are more comfortable with. So just make sure that you go back and answer the essential question and write your summary.